So here are some examples of finding the domains of radical functions. It says find the domain of each function. 1. Y equals x minus 3. Well, the argument is x minus 3, and the rule is that for square roots, that is an even index, 2 is an even number, of course. The index of a square root is 2. So for an even index, we need to take the argument and set it greater than or equal to 0 to find the domain. So we set x minus 3 greater than or equal to 0 and solve that by adding 3 to both sides, and you get x is greater than or equal to 3. And you can check your answer by drawing a number line and check the endpoint. The endpoint would be where the argument, also known as the radicand in this case, where that is 0, and then check a point to the left and to the right of it just to make sure that you shaded the right direction and you don't have the inequality go in the wrong direction. This is especially important if the coefficient of the x was negative, because people make mistakes on those more often than not. So you see, if you plug in 0 to the left of 3, right here, plug 0 in here, you get square root of negative 3, which is not a real number. So 0 is not in the domain. If you put in 3, which is the endpoint of my interval, you get square root of 0, which is 0. And that's where what we call the vertex would be. And it's, for square roots, the vertex is the endpoint of the graph. And then if you put in a number to the right of 3, which is what this is, x is greater than or equal to 3, the solutions. And that should work. That should give me a real number. And sure enough, it gives me square root of 2, which is a real number. So in interval notation, that looks like this: square bracket 3, comma, infinity, parenthesis. It's just a shorthand for this interval. So you just look at the interval and go left to right, always left to right, and write the numbers down. Don't ever write the numbers down right to left. I've seen way too much of that, and it's always wrong. Okay, f of x equals 5 minus 2x. Take the argument. It's a square root still, so index 2, which is even. So take the argument, or the radicand, 5 minus 2x, set it greater than or equal to 0, solve. And I solved it this way just for example to show you how to do this correctly. And then I get to this step here, I just subtracted 5 from both sides. And then in order to get this sign right here, I don't divide by negative 2. I just change the sign, and change the sign. Now I can divide by 2, and the inequality is not going to be going the wrong direction. So I get x is, I just cross multiplied. You can cross multiply positive numbers, but not negative numbers with the inequalities. So it's 5 halves. X is less than or equal to 5 halves. Okay, and I could check it on a number line. There's 5 halves. And if with the negative exponents on the variables, I recommend definitely checking these. So 5 halves, 0, 5 halves, and 3 are just test points I picked. F of 0 is 5 minus 2 times 0, which is, square root of 5 minus 2 times 0. Wait, stop. Here. Which is square root of 5, which is a real number. So that side should definitely be shaded. If I try 5 halves, I should get 0. And sure enough, I do. Square root of 0 is 0. And if I try 3, I get square root of negative 1, which is not a real number. And so I did get the right I did shade in the right region, and I have the right endpoint or vertex. So writing out the interval for it. Again, the interval is, remember, the interval is just shorthand for the number line. That's why numbers on the left on the number line are always on the left on your interval. If you're not thinking of it as part of the number line, I can usually tell because you'll get some of these backwards. So you start at the left. The left arrow is negative infinity, right? That's what negative infinity means. It's just this left arrow. And then it goes up to 5/2. That's a square bracket because 5/2 is a solution. We just showed it right here. See, it's 0. It's a real number. You get 0 out when you plug 5/2 in. Okay. So next example is y equals cube root of 3x plus 1. The domain here is all real numbers because 3x plus 1 is a polynomial, so it doesn't have any restrictions on x, on its input. And the radical has index 3, which is odd, and so also puts no restriction on its argument. So there's just no restriction at all on what x can be. So the domain would be all real numbers. Or if you want to write it in interval notation, it's parenthesis, negative infinity, comma, infinity, parenthesis.